All right, guys, here we go. Let's get started. So this is Notice 28, Law of Sines. It's going to be pretty fast. We're going to derive this from the area formula of a triangle. And we already know what the area of a triangle is. It's this one. Yes, you can say 1/2 base times height, but what if you don't have a perpendicular height or it's not a right triangle? Here's how you find your area. If you have an included angle with two sides, B and C. So we already know that's one of them. So I'm going to say area equals 1/2 BC sine A. So here's another one. 1/2, and I'm doing the same triangle. So if I use sine B, I need A and C. So AC sine B. And if I do angle C, then I need side A and B. So 1/2 AB sine C. So do you guys agree that all three of those will give you the same area of that same triangle? So what we're going to do is we're going to set them equal to each other. So we're going to write 1/2 BC sine A equals 1/2 AC sine B equals 1/2 AB sine C. And then we're just going to cancel some stuff that we can cancel out really quick. That half, because there's an equal sign on all of them and it has a half on all of them, we can just cancel them out. We're going to divide each single term or each one of these products by ABC. And when we do that, here's what happens. B and C cancel out, A and C cancel out, and A and B cancel out. So we're left with this. Sine A over little a equals sine B over little b equals sine C over little c. And what do you think they call this? Yeah, they call that law of sines. And I know if you Google it, you might not see it written that way. It might be written this way. It might be written as A over sine A, B over sine B, and little c over sine C. They're the same thing, guys. They're both law of sines. Cool or not cool? Cool. Now we're just going to use it. It's pretty basic. So let's see if we can do it, guys. So draw a triangle. I'm going to put not to scale. Not to scale. Triangle ABC. A, B, C. They tell you that angle B is 64 degrees. So I'll put 64. They tell you that angle C is 38 degrees. 38. And then I want you to find the lengths of side A and side C. All right, we all took geometry, so we know that all three angles in the triangle must add up to how many degrees? 180. So the first thing I would do is figure out what angle A is. That's what I would do. So 64 plus 38 plus angle A must equal 180. 64 plus 38, 64, 74, 84, 94, 104, 102. 102 plus A equals 180 degrees, degree. And then if I subtract that, I get 180 minus 102, what's that, 78? So 78 degrees. What's up, Nels? Third period, got it. Yes, okay. Oh, looking sharp, Nels. Nels is always sharp. All right, here we go. So now that we know, we're just going to use it, guys. Little b is 9. So this is little b, and this is little a, and this is little c. And we're just going to go ahead and go right to it, guys. So if I want angle little a, I'm going to write sine 78 degrees over little a equals sine 64 degrees over 9, because that one I know. And then from here, all you're going to do is cross multiply. So I'm going to put an arrow. So all I'm doing is cross multiplying, guys. A sine 64 degrees equals 9 sine 78 degrees. And then how do I get little a by itself? That's you. Not everyone at the same time. We divide by sine 64, right? That's how you get little a by itself. So little a is equal to 9 sine 78 degrees divided by sine 64 degrees. Make sure your calculator is in degree mode. And I already forgot the numbers. 9 sine 78, short-term memory. 9 sine 78 divided by sine 64. There it is, guys. 9.7946. 9.7946. Is that what you guys got? And I need units. Feet. Now I'm going to find, let's see, I already found little a. Now I'm going to find little c. I'm still going to use, yes, you can use little a if you wanted to, but I'm still going to use sine 64 over 9 because that's a perfect integer. And I don't want to like round, like I want my number to be perfect. So I'm going to write, let's see, what am I going to write? I'm going to write, what do I want, little c? So sine 38, I'm doing it in blue. I'm doing this in blue so it can indicate that I'm doing a different one. Sine 38 over little c equals sine 64 over little 9, or over 9, sorry. I'm still just going to cross multiply, so I'm going to put an arrow. And is it okay if I just write c equals? C equals, let's see, 9 sine 38 degrees divided by sine 64 degrees. See? You just type it. So we're just going to go 9 sine, was it 38? Divided by sine 64. And 6.16487 if it's truncated. 6.16487 feet. Or 8, you can say 8. And there it is, guys. What do you guys think? Pretty simple, right? All right, so you guys see if you guys can do example 2 faster than me. I was tired when I was writing these notes, so I put the same degrees. My bad, guys. Next time I'll create a better problem with different angles. But see if you guys can do it faster than me. Bless you. It's the same triangle pretty much. This time I gave little a. Eight sine 64 over sine 78. That's what the little b is. Did you guys get a number for that? Can you guys hook me up with it? I guess I could do it. 3509 meters. All right, hook me up with the letter, with the blue one. C equals 8 sine 38 over sine 78. 8 sine 38 over sine 78. Is that what you got? 5.03532? 33 if you want to round it, but no big deal. How do we feel, guys? Pretty easy, right? And that's what you're doing today over and over again. Now you see these questions here. These are questions that are going to be This is not from the law of sines and cosines. This is from trig. I think it's called triangle problems, which is going to be a test grade. So we're going to do them together, so you can see they're not that bad. Cool. So says this. What does it say? The triangle ABC with side BC as the base. Okay. So I'm gonna put not to scale, guys. So here we go. ABC. ABC. The measure of angle A is 60 degrees. Okay, 60. If a perpendicular is drawn from B to side AC. Okay, from B to side AC. So here's my perpendicular. Pretend that's a right angle there. The height is 8 centimeters. So that's supposed to be a right angle there with the length, with segment AC. What is the side of AB? Okay, I like it. I like the question, guys. I hope you guys like it too. There's so many ways to do this question. Do you guys want to do that one with law of sines, and we just covered law of sines just right now? Okay, let's do it with law of sines. Pretend that's the only triangle you see, the green one. I'm going to call this vertex here x. So this is length x, little x. So, and by the way, this has to be a 90-degree angle, right? So we're just pretending we just have that green triangle. So if we want to do law of sines, you can just go, let's see, sine 60 degrees over 8 equals sine 90 degrees over x. And there it is. That will give you the answer, guys. Let's see, what is that? X equals 8 sine 90 degrees over sine 60 degrees. I don't necessarily think this is the easiest one. Bless you. 8 times, what's sine of 90? 1. Divided by sine of 60. Do you guys remember what that is? Square root of 3 over 2. Yeah. And then just go keep change flip. So 16 over square root of 3. So if you want to rationalize it, 16 square root of 3 over 3. I don't necessarily think that's the easiest route. I think there's an easier route. You guys want to see the other route? Do you remember the relationship between a 30, 60, 90 triangle? What is it?
This is 2x. The opposite side is x.
Perfect. I'm going to use n so we don't confuse it with the x, you know what I mean? So n squared root of 3, and 2n. What you're looking for, this is the hypotenuse of that green triangle. So what you're looking for is 2n. We know the long leg is whatever's across the 60 degrees, so that's 8. So you just go n squared root of 3 equals 8. Divide by square root of 3, divide by square root of 3. So little n is 8 over square root of 3, but that's not what I want. I want 2n. So if I want 2n, all I got to do is multiply 8 squared root of 3 by 2. So 8 over square root of 3 times 2. And I guess I should have put the 2 in the front, right? To be consistent with 2 times n. 16 over square root of 3. So there it is, guys. 16 square root of 3 over 3. Same thing. So it doesn't matter how you do it, guys. If you understand the concept, you'll get it right no matter what. Are you guys awake? You guys are looking at me like, some of you, and then some of you guys are like writing really fast. All right. This is actually one of my favorite problems. It comes out all the time in like SATs, ACTs. So maybe it came out just in time for tomorrow's SAT, guys. If you remember the area of a regular polygon, do you guys remember how to find the area? Do you guys know what apothem means? 1/2 apothem times perimeter. You guys have? Okay, then don't worry about it. Do we know what a hexagon is? How many sides does a hexagon have? So draw a regular hexagon. An irregular hexagon would still be 6 sides, right? It would just look like deformed. Let's see. 1, 2, 3, 4, 5, 6. There's my hexagon. Not super awesome, but that's fine. And it's inscribed in a circle, so that means each vertex is touching a circle. So let's see if I can do that. My circle is kind of thick, or I don't know how to say it, squishy circle, or more elliptical than a circle, but that's fine. And then here's what I would do, guys. Here's how I would do this question if I saw this on the SAT. I see how many triangles? I see 6 triangles. And I know that the radius is 4. So this distance is 4. This distance is 4. And we just learned a little while ago how to find the area of that triangle if I know this angle. Travis, I don't know that angle though. Yes, you do. You don't need to know properties of polygons to know this angle. Yeah, you're right. It is 60. 1 revolution is 360. There are 6 triangles there. So 360 degrees divided by 6 is 60. Do you guys see that? So area of one triangle, area of one of those triangles is 1/2 base, or 1/2 side times side, sine of 60. You don't need a calculator for this. You can just, 1/2 of 4 is 2. 2 times 4 is 8. Sine of 60 is square root of 3 over 2. And then 2 goes into 8 4 times. So 4 square root of 3. But that's the area of one of them, of one of the triangles inside that hexagon. How many triangles do you see total? So we're going to multiply this by 6. So 6 times 4 is? So your total area is 24 square root of 3 square centimeters. Don't say centimeters squared. That's how you write it. But when you say it out loud, you say square centimeters. And for those of you that are in chemistry, when you get to it, when you get to volume, do you say feet cubed or do you say cubic feet? Cubic feet, guys. That's the unit feet cubed, but you say cubic feet. All right. How many more questions we got? 2 more? All right, we're almost done, guys. This question here. I like this question. By the way, put an asterisk on it. It's in your exam for the 9 weeks, which will also be a semester exam. Oh, we'll just, you know what? We'll delete the 9 weeks exam. No, we'll just call it a semester exam. All right. On a acute triangle ABC, the measure of angle A is 2x. The length of AB is 4, and the length of AC is square root of 3. If sine x equals 1/5, what is the area of the triangle? Not to scale. Let me draw a triangle. ABC. Angle A is 2x. Length AB is 4, and length AC is square root of 3. That's all you need. So area of this triangle, I'll write it down here. Area of this triangle is 1/2 times 4 times square root of 3 sine of 2x. And now, and then they tell us that sine x is 1/5. So we're going to use that in a little bit. It tells us here to use our double angle formula. So side note, do we know what sine of 2x is? 2 sine x cosine x? Yes. We derived this from scratch, guys, so don't write this down, just listen. So we're going to continue with the side note. Do you guys remember? Bless you, bless you. Do you remember when we said sine A plus B? Don't write this down, just listen. And then can you tell me the composite argument property for sine A plus B? Yeah, see, so it's easy for you guys now. So if I replace one of those letters, instead of calling it A plus B, if I go A plus A, then it would be sine A cosine A plus cosine A sine A. And then how many of those do you see? So I can say that sine 2A is equal to 2 sine A cosine A. And remember, we spent like a whole week doing that. Now you can do it in like 30 seconds. Isn't that cool? I think it's cool, guys. I really do. So this is what we're going to use. So we already know sine x. You don't have to write the stuff in black other than the one that I circled, because that's the only thing you're going to know. You need to know for this one. I'm going to draw a right triangle. Don't get it confused for the one over there. I'm using this right triangle to figure out what cosine is, to figure out what cosine x is. So they told me that sine x was 1/5. So here is me forcing a 1/5 in the triangle. So if I want to figure out what cosine is, I need to figure out that adjacent side. 5 squared is 25. 1 squared is 1, and I'm going to subtract them because I want to figure out one of these legs here. So this is going to be the square root of 24. And then what two numbers multiply together to give me 24? 6 and 4. So the square root of 4 is, so 2 square root of 6. So now I'm ready. If you want, you can write it here on the side. That means that cosine x equals 2 square root of 6 over 5. Now we're ready. 1/2 times 4 times square root of 3. And I'm going to replace this. I guess I'll do it in 2 steps. I'm going to replace this with 2 sine x cosine x. Area of the triangle is 1/2 times 4 times square root of 3. You can put that together, 4 square root of 3 if you want. Times 2 times sine x was what? 1/5 times cosine x is? Perfect. Now I'm just going to start multiplying, guys. You don't need a calculator for this. 1/2 and 2 cancel out. Let's see. 4 times square root of 3. I guess I'll write it as 4 square root of 3. And then, let's see, times 1 times 2 square root of 6. All this is over 25. Don't worry, we're almost done. 4 times 2 is 8. And square root of 6 times square root of 3 is 6 times 3 is 18. Square root of 18 over 25. You could leave it like that, but you're not going to have the right. If it's multiple choice, that answer is not going to be in there. 18 breaks down to what times what? Oh. You can say 6 and 3, but then we'd have to break it down again. So what's a better one? 9 and 2. What's the square root of 9? 3. So what's 8 times 3? So 24 square root of 2 over 25 is my area. Do you see how we did it, guys? The 2's because that's what you still have inside the radical. 24 square root of 2 over 25. How do we feel? We feel okay? We got one last one. Oh yeah, there's the ambiguous case. Since they don't tell us ambiguous case. They don't tell us 2 other angles. Let's see. Not to scale. All right. So this one's going to have 2 possible answers, and I'll tell you why in a little bit, guys. They tell us that A is 15 and B is 8. So I'm going to draw this triangle for now. And I'll show you something, well, not too bad. I already drew it that way. So A, B, C. So little a is 15, little b is 8, and little c we don't know. Find all possible measures for angle C. They tell us that the area is 14. So I'm just going to use my area formula, guys. And I'm just going to set it up. So I'm going to write 14 equals 1/2. And let's see, if I'm using angle C, so I need 8 and I need 15 sine of C. So hopefully you can already see the game plan. You want to isolate sine C. So let's see, 14 equals, half of 8 is 4. 4 times 15, 15, 30, 60. 60 sine C. And then how do I get rid of the 60 there? Divide. So now I'm going to have sine C equals 14 over 60, which reduces to 7 over 30. 2 goes into 14 7 times, 2 goes into 60 30 times. And now to get C by itself, I guess I'll write one more line. Sine C equals 7 over 30. To get C by itself, you got to take the arc sine, the inverse. And let's see what that answer is. So we're going to go arc sine 7 over 30. Make sure you're in degree mode, and I get this answer, 13.4933. because they didn't give us two other angles, guys, they didn't give us angle A or angle B, I could also have another one. What else could I have? Take that answer that you got there and subtract it from 180. 180 minus second answer. And don't worry, we'll prove it right now. 166.5066. So let's see if this really does work. Let's see. You see this right here? I want to see if I get the area of 14. So I'm going to write 0.5 times 8. Oh, man. Times, what was the other number? 15? Times 15 sine. Obviously, the 13 sine of the 13 is going to work, but we'll still test it. So let's see. If I push enter, this better give me what? 14, because it is my area formula, guys. Well, okay. There's funny rounding going on because I didn't store this to memory. So because of it's using that 12 there, it's 13.999999998. Is that 14? It's 14. If I do the same thing, 0.5 times 8 times 15, I suspect it's going to be the same. Like it's not going to be a perfect 14, it's going to be 13.999 because I'm using the rounded answer instead of the perfect answer, the perfect degree. Okay, that one, this time it gave it to me perfect. So 14, but it's 14. Both of them work. Do you guys see how both of them work? Cool. You know what? I don't like that it was 13.99. Let me do it again. But this time I'm going to do it like this. 180 minus arc sine of 7 over 30. Just for kicks, guys. So there it is. I'm going to store this to A. I guess I should have used the letter C. 0.5 times 8 times 15 times sine of A. Let's see, is it going to work? Okay, now it works. Because we're using the exact. Isn't that cool? All right, we're done. Hopefully you saw that they were not too bad, guys. You should have enough time to finish this because everyone did yesterday. If you're ambitious, you can do law of sines and cosines and the UH or UH, and that's it, guys. Let me find the others. Oh, here they are. Here you go, guys. It should work. Oh, it's not plugged in. It's not plugged in. You want to plug it in?